Hi all, this is a video on dealing with cubed roots and fractional exponents. So how do we reduce something that is asking us to take a cubed root of a fraction? Some of those fraction parts have variables raised to powers. So let's see how to deal with this guy. So the first thing we want to do is deal with the fraction independently, and the rules for radicals allow us to do that. So I can just look at the cubed root of z to the 5th power over the cubed root of 8x to the 6th power independently. So the next thing I want to do when dealing with cubed roots is turn them into fractions, and I know that actually sounds counterintuitive and kind of terrible, but it will allow us to reduce fractions to be able to solve these cubed roots, which is a much easier way than the traditional way of prime factorizing everything and looking for what the cubed root has in common with all of the factors. That way can be misleading and time consuming. So let's just try this other method of reducing fractions. So I'm going to rewrite the numerator as z to the 5th power all raised to the 1/3, which is how I write a cubed root as a fractional power. In the denominator, I'd have the same thing, 8x to the 6th power, all raised to the 1/3 power. And now I don't have to write my cubed root anymore. The next thing I want to do is look for 3's in my powers. So when dealing with the variables, this can be easier to do because they're already raised to a power that I can look for 3's in. But for my numbers, I have not done that. And there is no power there for me to look for 3's. So instead, let's write this 8 here as 2 cubed, because that is a perfect cubed representation of 8. And if I didn't see that, I could always try and prime factorize the number. So that would be 8 is 2 times 4, and 4 is 2 times 2. So circling all my primes, I have 8 is equal to 2 cubed. Alright, let's go back and rewrite this as, trying to change back to blue. There we go. Z, why is it so big? There we go. Z to the 5th power, and I'm going to bring that power inside and write it as 5/3. So across parentheses is a product, so I can mush these together as 1 fraction 5/3. In the denominator, I'm going to write this as 2 cubed, and I can mush this 1/3 in here, so over 3. X to the 6th, and again, over 3. Now I'm going to try and reduce as many fractions as I can. In the numerator, I don't have anything to reduce. 5/3 doesn't reduce, but it is an improper fraction. So let's keep that in mind. The numerator is larger than the denominator, so that means I still have to deal with this. So let's go ahead and just circle it so we don't forget. This is an improper fraction. That's not okay. And let's reduce the fractions in the denominator. 3/3 is really 1, and 6/3 is really 2. So we'll just rewrite the denominator because that appears to be done. I don't have any more denominators of 3, and I don't have any improper fractions, and everything has been reduced. So I have 2 to the 1st power, which I can just write as 2, and x to the 2nd power. To deal with this 5/3, I have different methods I can do. I can do the method where I say, well, 5 is really 2 plus 3, put those both over 3, and then reduce each one individually. I can also write the improper fraction as a proper fraction, or in other words, turn it into a mixed number. If you don't remember how to do that, you would divide 3 into 5, which goes in once, with a remainder of 2, and you would write the rest of the fraction that way. So this would be z to the 1 2/3. Alright, doing that allows me to rewrite that. That's 1 2/3, which represents a addition sign. So that's z to the 1st times z to the /2 over 2x squared. which would give me, if I rewrite this, since it's no longer an improper fraction, I know I'm completed that, z cubed root of z squared over 2x squared. Okay, so that's one way of dealing with this improper fraction that I had. So this guy was the difficult one to deal with because everybody else reduced simply. But this z in the numerator was an improper fraction and the 3's didn't work for me. So it's one way of looking at that problem. So let's do it one more time. This time we'll do it in a pretty purple color. So that was the cubed root of z to the 5th over the cubed root of 8 x to the 6th. We rewrote that as z to the 5th to the 1/3 over 8 x to the 6th to the 1/3. Alright, so for the numerator and for the denominator, let's deal with this separately. So z to the 5. I'm trying to look for as many 3's as I can possibly find in 5. So 5 is 2 plus 3, and that's as many 3's as I can get out of 5 to the 1/3. As we said before, 8 is really 2 cubed, so 2 cubed is as many 3's as I can get out of 8. And x to the 6th, I can write that as 3 plus 3, all raised to the 1/3 power. I'm going to distribute again, so this gives me z to the 2/3 plus 3 over 3 over 2 to the 3 over 3, x to the 3 over 3 plus 3 over 3. Let's go back and reduce our fractions again. This turns into a 1, this turns into a 1, this turns into a 1, and this turns into a 1. Okay, so on the next slide, let's rewrite that. So that was z to the 2/3 plus 1 over 2 to the 1st power, x to the 1 plus 1. And now we're just going to use the rules of exponents to separate the numerator. And the reason I would do that is because I have partial fraction and partial whole number. And so that tells me that I shouldn't try and reassociate them. I'm just going to go ahead and separate them. That gives me z to the 2/3 times z to the 1, because the rules for exponents tell me if I'm multiplying, then I add the numerators, or sorry, the exponents. And in the denominator, that's a 2. And since these aren't fractions and they have a common denominator, I can just put them back together. 2. Rewriting this, I have z. I'll turn this back into my square root or cubed root notation. Cubed root of z squared over 2x squared. So it's two different methods from what the book did to be able to deal with these. There's lots of methods for these, and hopefully that expansion into new methods helps you find one that works for you. On the exams, I do not care how you solve these as long as what you do flows logically and I can understand how you got to your solution. So whatever works best for you. Hope that helps, and I'll see you soon. Bye.